Welcome. Thank you for coming, and for those of you who are tuning in on cable, thank you for tuning in to West Hollywood Fault Lines. My name is Susan Duenas, and I work in the city's public safety office as a neighborhood services specialist. To begin, I'd like to introduce the committee who is presenting us this presentation tonight, our Disaster Preparedness Committee. Over here we have Robert Raff, Barbara Zampelli, and Don Westlake. And they will be assisting us in the question and answer period of our presentation. And now, Robert Raff, to introduce our feature presenter.
Thank you. And thank you for coming. I'm Robert Raff, Chair of the Disaster Preparedness Committee. And I'd like to welcome you all here tonight. We're very fortunate tonight to have with us Dr. Kerry See, a professor of geology at the Caltech Institute. He received his PhD from Stanford University, and some of you may have seen him on local TV news broadcasts. Dr. See?
Thank you very much. I'm going to try to negotiate this in one hand and this laser pointer in the other, and hopefully I won't make you dizzy with it by going like this through the whole talk. I don't live in West Hollywood, but I live close by, and I have an abiding interest in the safety of the city. And so tonight I'm going to be talking to you about, I'm going to be stepping back first and looking at the earthquakes around the entire globe, and then I'm going to focus in fairly quickly on the Los Angeles area, talk a little bit about the Northridge earthquake and other historical earthquakes we've had, and then I'm going to talk specifically about what we've learned recently about the earthquake hazard specific to West Hollywood and neighboring communities. Like Susan said, if you have questions, please write them down during my talk. That'd be fine, and hand them to the committee, and then they'll, if they're legible, they'll read them, and hopefully we'll have a good session at the end of the talk. I'm going to use slides. Scientists such as myself usually use slides as prompts to remind us where on earth we're going with our presentation. So if we can start with the first slide, I'd appreciate it. The butterscotch pattern you see here is a pattern that outlines or covers most of the world's earthquake localities. So most of the places where earthquakes occur in the world are in these bands. The Himalayas here have a large number of big earthquakes. Turkey, Iran had an earthquake a couple of days ago. Let's see, I think I hit Iran, yeah, right about here. The Mediterranean region has had big earthquakes in the historical period, and Alaska, Japan, you may know. The Philippines had a really big earthquake about 3 years ago. Since the Northridge earthquake, there have actually been 2 earthquakes bigger elsewhere in the world. The area here in eastern New Guinea had a magnitude 7, and then where was the other one? There was another one, Sumatra, right here, where there's a fault much like the San Andreas fault, and that part of that broke just about 2 weeks ago. So you can see that we also, along with the west coast of most of Central America, all of South America, all of Central America, and most of the west coast of the United States, going up to Alaska, all have major earthquakes. The yellow or red dots, by the way, are major volcanoes. Now you may ask, why do we have these belts of activity rather than just blotches of activity, or why not earthquake activity all around the entire, everywhere in the globe? Next slide. We have a phenomenon called plate tectonics that was only discovered about 30 years ago, and the reason it's called plate tectonics is that the Earth's crust, the upper 60 miles or so, from here down to about 60 miles, consists of a dense, fairly cold slab of rock, and that dense material is being forced to move by very slow convection or motions, circular motions like this, in the gooey, plastic, sort of taffy-like material down below us. Now that's not molten, but it's like it's so hot that it's actually of a taffy consistency rock. So those motions cause the crust to split apart in certain places, for example, in the middle of the Atlantic Ocean and the eastern part of the Pacific, and the plate then moves in this direction, the direction of that arrow, and then in places that we call subduction zones, don't mispronounce that, we have this cold material descending back into the lower gooey material and melting, partially causing, in places causing volcanic activity. And in other places, we have the plates moving along faults like the San Andreas Fault here. So this sort of motion, this plate's moving this way relative to that plate. So that's called plate tectonics. And that's basically the reason we have earthquakes in California. Next slide. So when we outline the plates with nice colors that make them easier to see, we can see that here is the Pacific Plate, the biggest plate on the face of the Earth. It's about 8,000 kilometers from here to here, or about 5,000 miles for those of you who aren't bilingual. And here's the North American Plate, running from the middle of the Atlantic all the way through New Jersey, all the way out to California. And then here are the other big plates. Eurasia includes most of Asia, Southeast Asia, and most of Europe. Africa here, which sort of gets short shrift on this slide, it continues way over to here. The South American Plate, the Scotia Plate, the Caribbean Plate, lots of little minor plates, the Australian and Indian Plate, and so on. So earthquakes happen wherever the plates join. If you overlaid that butterscotch pattern of earthquakes, you'd basically see these plate boundaries. Next. Let's start looking a little bit closer now. Let's take a look at California. Here's Arizona, Utah, Idaho, Oregon, Nevada. You can see that California has more than its share of small earthquakes. These are just, some of these earthquakes aren't even felt. Okay, magnitude, there were probably on the order of 20 or 30 magnitude 1.5 today somewhere in California that we can't feel. So this pattern of earthquakes shows that really this entire area is part of the Pacific North American boundary. But in fact, the majority of the motion occurs along a fault that we have right here, just north of us, about 40 miles, called the San Andreas. Okay. Next slide. Now, here's a little physiographic or plastic relief map that shows the physiography, the topography of California. And let me just point out that virtually every mountain that you see in California and virtually every mountain you see in Nevada is related to earthquakes. Now, Mother Earth operates over time scales that are incomprehensible to us. We may live 100 years if we're lucky. Almost nothing happens on the face of the Earth in 100 years. The forces that produce earthquakes produce them on the order of every couple hundred years in one place for any one fault. So all of these mountains have been produced in about the past, 5 million years, which is a twinkling of an eye to the earth gods, but an awful long time for us. So we're not going to see all these mountains rising, all the valleys sinking down in our lifetime, but by the luck of the draw, or the bad luck of the draw, some of us are going to be right on top of where these earthquake faults move and raise the mountains and sink the valleys. And that's what happened down in here. Now the San Andreas Fault runs along here, up like this, up toward Monterey Bay, and then up off of the San Francisco, the Golden Gate, up through here, and then out like this to Cape Mendocino. You may recall there was a magnitude 7.2 up here at Mendocino and a magnitude 7.2 out here in the Mojave just a year and a half ago. They were actually fairly far away from major metropolitan areas, so it didn't really sustain much damage. Next slide. This is a slide that you have to ignore the red line here. It has other purposes, but these are the 3 great earthquakes that we've had in the historical period in California. So one of them you all know, the San Andreas Fault broke here in 1906, and this is the area that suffered severe damage, okay, during that earthquake, all the way from Monterey down to San Juan Bautista, all the way out towards Sacramento, all the way up to Mendocino. Our equivalent great earthquake on the San Andreas was in 1857, and it produced damaging intensities all the way through the northern part of LA County and out towards San Bernardino, and then up into the Mojave and Bakersfield and so on. For reference, here's the damage area, the major damage area for the 1971 Sylmar earthquake. Okay? Now, it's not necessarily the case that the shaking was a lot stronger here in 1857. In fact, in San Fernando Valley, it wasn't as strong, but it lasted about 4 or 5 times longer. So people who felt the 71 earthquake or the earthquake at Northridge a month and a half ago will probably not experience stronger shaking. But if there's ever a great earthquake in the San Andreas Fault, let's say this part breaks, the number of people affected will be much, much greater. West Hollywood was probably able to help out some of the local jurisdictions in the San Fernando Valley. That might not be the case when a great earthquake happens. Next. So enough of the San Andreas Fault. Here it is running across the countryside between the Mojave Desert. Here's Palmdale, Lancaster, and the LA Basin, San Gabriel Mountains here. All the topography you see here has been produced by earthquakes over the past several million years. So, where are we? We are today right here in West Hollywood. Here's the Hollywood Hills, Santa Monica Mountains. Here's the San Fernando Valley. And the earthquake that happened a month ago started here, but it involved a fault that is buried beneath the northern San Fernando Valley right here. These mountains, the Santa Susanas, rose about 15 inches during the earthquake. They're a total of about 4,000 feet high. So you can imagine how many earthquakes have happened. This is nothing from Mother Nature. It's just a big deal for us. Next slide. Well, here's a figure that hopefully you can see. It shows, again, the Santa Monica Mountains, Hollywood Hills, some of the major freeways, some of the major towns. And it shows the main shock of the earthquake, which began here about 18 kilometers or 12 miles beneath the surface. And the fault ruptured up toward the mountains in this direction, so that if you looked at the fault plane in map view, it would be underneath this part of the San Fernando Valley. And all these little dots are aftershocks. The pink ones are magnitude 4s and greater. These two red ones over here are magnitude 5 or greater earthquakes that hit the Simi Valley within a few days of the main shock. And all the orange ones are magnitudes less than 4. So we've had thousands of earthquakes located in this area just since the main earthquake. And the reason is that when the fault moves here, it causes stresses around the edges of itself, and those stresses cause little earthquakes in the neighborhood. For the first time in years, we actually had a few little earthquakes here in the Santa Monica Mountains, just north of Beverly Hills. So the stresses in the hills here were actually built up a little bit by the earthquake. Next. I'll just show you a few of the slides. You probably actually saw more of the damage than I did, because I never had a chance to watch television in the few days after the earthquake. I was too busy talking to all you folks. Anyway, here's one of the parking structures that collapsed during the earthquake. Next, this is near Cal State Northridge. Here's the bullocks that fortunately nobody was in. You can see that the floors collapsed as well as the exterior walls. Next. I won't show you lots of pictures of damage. I'm not really an engineer. And I apologize for the poor quality of this slide. It's the first time I've tried to show it. And this is the FEMA or county building damage map. All these red dots are buildings that were damaged in the earthquake and were declared unsafe and uninhabitable. You can see there actually were some down here. This is near where the freeway, where Interstate 10 collapsed. And as a matter of fact, I just want to show you that my benefit from being at this meeting is a little piece of the rock that Chris Petrucci, who just started a business over here in town, collected and broke up. So if you want a piece of the freeway, you just go to talk to Chris and let loose of $4.50 or so, and you can get a nice package. But I don't get paid for that commercial, by the way. Damage here along Ventura Boulevard, damage in here, seems to be associated, and also a lot of damage here in this part of the San Fernando Valley, seems to be associated with places where the water table is very close to the ground surface. So a phenomenon we'll talk about a little later tonight at the very end of my talk, liquefaction. It seems on first glance anyway that some of the places in town in the metropolitan region that had very high water, that is water very close to the surface, sustained unusually high levels of damage during this earthquake. Even areas that were well away from the main shock down here near the I-10. Next slide. Just a couple of slides of one of the things I want to emphasize today. One of West Hollywood's most serious problems with respect to earthquakes is not just the collapse of buildings or buildings that aren't properly anchored shifting off their foundations. Another very serious problem for all of us in the metropolitan region is the disruption of infrastructure. The picture I'm showing here was taken up in the first about an hour or two after, 2 or 3 hours after the earthquake, and it's an enormous fountain of water coming up where there was actually liquefaction, cracking in the ground, and a water main broke and was spouting water up on the order of 150 feet in the air. This flooded large portions of the northern part of Granada Hills actually that morning. Next. And of course the freeway collapses. This is the 118 between the 210 and the western part of the valley. Next. And then here, still smoldering, are the mobile homes that were burnt because of the breaks in gas lines. Next. And this is the spectacular Rinaldi and Balboa Boulevard jet of gas that was burning for hours after the earthquake. The gas was actually coming up through the water mains that had broken and still had ignited. You may recall reading about this guy who had started his truck after the earthquake, and the spark from the ignition ignited this and blew him and his dog not away, but blew him around a bit. I think he survived. But these houses then burnt because of the fire. So infrastructure is a serious issue in West Hollywood as well as in surrounding communities, and I'll talk to you now about some of the faults that we have in West Hollywood and neighboring areas, and they will produce breaks in water mains, breaks in gas mains if they in fact move during a big earthquake. So this is something that I think the citizenry has to somehow come to grips with and decide what to do. Next. This is a figure that was, well, you may have seen in either Newsweek or Time magazine, I can't remember which, and for once in my experience, they got it basically right after talking to the scientists. Here are the San Gabriel Mountains, north of the valley. Here's the fault that broke in the 1971 earthquake. Here's the San Andreas Fault way over on the Mojave side. This fault moves like this, so sideways, horizontally. In the basin, most of our faults move vertically like this. So this block moves up relative to this one, or this block moves up relative to this one. So this is the fault that produced the earthquake hidden beneath the San Fernando Valley. This is the one that produced the 1971 earthquake. It actually comes up to the surface and breaks the ground, and I'll show you some pictures in a minute. These are the Santa Monica Mountains, and this section is cut a little bit west of us in the ocean. So the Santa Monica Fault runs here and comes up under the sea west of us, but it also runs through Santa Monica, southern Beverly Hills, and then it jogs up to become the Hollywood Fault, which runs along the base of the hills here, along Sunset Strip. Next. Okay, so let's talk now about some of these faults that are in this area close to us. Next. Actually, let's back up one. Can we do that? These hills are here for a reason, and the reason is that they're a pucker in the crust that's occurring because there's a fault hidden beneath them, and that fault is mostly hidden beneath them, and it's moving the materials above it this way, but it's sort of locked at its tip, so it can't move at the tip, so it crinkles up the Santa Monica Mountains and the Hollywood Hills. Well, some of the fault actually breaks to the surface along the north of Franklin, and then in the eastern part of Hollywood, or northern part of Hollywood. Then it runs down the strip, and then it runs through parts of East Beverly Hills. And I'll show you a little bit of evidence for that in a second here. But first, let me show you where the faults break the surface, like they did up here in 1971, what they look like, and then we'll see what they look like down in here where they break the surface. Next. So we're going to look at two kinds of faults. First, we'll look at faults that actually break the surface. This side moves up relative to this side, and there'll be actually breaks in the ground, breaks in pipelines, and so on. And then we'll look at faults that come along like this, ramp up, and then go flat again, and all they do is they bend the hills and make Santa Monica Mountains, Hollywood Hills, and some of our other famous tourist attractions. By the way, I think that what we ought to do, scientists are always very poor in their research. They have to really scrounge for the money. So one of my colleagues proposed a couple of years ago that since everything that tourists come to see in California is made by earthquakes, there ought to be an earthquake tax on every tourist. So every tourist that comes into town has to pay, say, $1 or $2 or $10 just to look at our beautiful mountains and our beautiful valleys. It goes into an earthquake research pool, and we can find all the answers for you in just a couple of years rather than always saying, well, we don't really know the answer. How's that sound? Okay, so I've got a possible voter initiative going here. Next. Okay, well, this is a picture of a geologist looking puzzled, looking at the rupture of the ground that occurred in 1971. This is in the area around Tujunga, and you can see the mountains here rose about 3 feet or so relative to the valley. Next. That little fault, by the way, went down about 13 kilometers or 9 miles into the ground, into the Earth's crust. Here's the same fault, but it happens here to break across asphalt and concrete. So you can see the mountains went up here, and the valley went down, and so you can imagine that your house wouldn't fare too well if you were sitting on top of one of these. Well, good news, some of you are sitting on top of one of these if you live in Hollywood or West Hollywood or Santa Monica. The good news might be that it only breaks every few hundred to few thousand years. Next. Now, if you happen to work just north of Capitol Records, you're sitting on one of these faults. This is taken from the intersection of Hollywood and Vine, an intersection of some renown, but for other reasons. But just north of Hollywood and Vine is this steepening of the road. This is Vine. There's the 101, and here are the Hollywood Hills, and going through Cahuenga Pass. And that little steep ramp right there is a fault scarp that's been produced over the last few tens of thousands of years. We don't want that to move. Next. Now, some of you who are at least as old as I am will remember this house. This house is a famous house. It's where the first Ozzie and Harriet episodes were filmed back in the 50s. And so this is the Nelson House. The Nelson House is northern Hollywood, and I won't tell you exactly where, but this house sits directly astride the Hollywood Fault, which is the fault that I showed you in the last picture. Here, the sediments have been coming out of the mountains, Runyon, what is it called, Runyon Canyon, Runyon Park or something? Coming out of the mountains fast enough through that park that they've buried the fault faster than the scarp can build. So you can't see it. It's hidden from view, but it has moved in the last few thousand years, so we know that it is potentially active. Because the city was basically developed before the special laws were enacted to avoid people building their houses and their structures on earthquake faults, this fault was never zoned, so the state does not have any regulations about building on this structure. So unlike people who live on the San Andreas who have some help from the state identifying where the structure is, here in Hollywood and West Hollywood, Santa Monica, we don't have that advantage. And so there are hundreds and hundreds of houses along these lines throughout the city near the mountain fronts. Next. Now here's one of the few places in Los Angeles that's not built, and this is the Western Regional Headquarters for the American Red Cross. I believe it's the headquarters anyway. And this is Ohio Street down here, and this beautiful little hill is a fault scarp also. This is the scarp of the Santa Monica Fault, which runs from the coast at Will Rogers State Beach all the way east through about where Santa Monica and Wilshire intersect. So near the Beverly, what's the hotel? Beverly Hilton? Yeah, near there. I don't know if it goes to the hotel, but it's near there. Okay. This fault we know from excavating across it and looking at the disrupted sediments, we know that it's broken at least a couple of times in the last 10,000 years. We don't know whether it goes every 5,000 or whether it goes every 500, and we don't know when the last one was, except that it was more than 2,000 years ago. Next. Now, those two faults I just was talking about are here, the Santa Monica Fault. Here's the coastline, here's the mountains. Here's Cahuenga Pass, where the LA River used to flow across. And here's the Hollywood Fault running through here. There's also a little fault here running along MacArthur Boulevard, which we call the MacArthur Park Fault, but it's east of us. One of the big questions that we don't understand we don't know the answer to yet is, do these faults break in little magnitude 6s or 6.5s like the Northridge earthquake, or do they break together 1, 2, 3, 4 all the way over to Whittier, in which case we might have a magnitude 7.5. We just don't know the answer to that yet. We're in the process of trying to figure out when the faults last moved, how often they move, so that governments and citizens can make better decisions about whether it's worth worrying about them or not. Now, let's look at a couple of structures that are hidden beneath the valleys, not just these ones that break the surface, but the ones that are beneath them that we can't really see directly. Next. This map is the same computer-generated topographic map. Here again is the San Andreas Fault, shown in red, and this is the aftershock region of the Northridge earthquake last month, and this is the aftershock region of the 1971 earthquake. Here's the Pasadena earthquake of 1988. Here's the Whittier Narrows earthquake aftershock zone of 1987. Here's the 1933 earthquake zone, the Long Beach earthquake, 1933. And all the areas in green are pieces of buried faults that haven't broken yet, historically. So we have a serious problem here in town. And sooner or later, our generation or the next generation or the generation following that is going to experience an earthquake generated on one of these hidden structures beneath us. So it behooves us to make some decisions about what is actually worth doing, given the likelihood of the hazard occurring. What is worth doing? What's worth spending our money on to harden us against these natural hazards called earthquakes? Next. Now, this is a geological figure, but I dare to throw it up because I know you're all very capable of interpreting these things. This is a map of well, you recognize a couple things here. We've got the Santa Monica Mountains over here in gray. Here's the Hollywood Fault. There's Ozzie and Harriet's right there. And then over here is eastern Beverly Hills. And then here's the Beverly Hilton. And then here's the Santa Monica Fault. Now, here's the San Diego Freeway. Here's La Brea Avenue. Here's the Harbor Freeway. There's a big basin full of sediment right here called the Los Angeles Trough. And then there's an arch called the Wilshire Arch right here that runs along Wilshire Boulevard. And there's a basin called the Hollywood Basin. Well, those basins and that arch exist because they're puckering from a fault that's moving down below. And that fault has moved a couple thousand feet in its history of a million or 2 million years, and probably is capable of producing magnitude 6 or 6.5 directly underneath this part of town. Now, in case you're feeling badly, I live right there. So it's part of my problem as well, and that's one of the hidden structures beneath the basin. So in addition to the structures that we can see at the surface in white here, here's the Newport Inglewood through Baldwin Hills, we have these hidden ones that are producing little welts in town. Next. Here's that structure in cross-section. Here's the surface of the ground, Hollywood Basins, Hollywood Fault, Santa Monica Mountains here. And here's the sediment that's warped into a broad, gentle arch. And here's the structure down here that produced it. Motion on a fault here, this side up, will produce that little warp in the ground. Next. That's hot off the presses, by the way. We only have known about that for about the last year. Okay, well, I've forgotten why I put this slide in, so let's just go to the next one. Oh, I know why. Let's go back. Okay, so let me just summarize where we have structures. Most people in the Los Angeles metropolitan area are within 5 miles of an earthquake fault. So all of us are potentially in a situation like the people who lived in Northridge and Granada Hills were in prior to the earthquake. The Palos Verdes Peninsula is coming up out of the ocean because there's a fault beneath it, and that fault runs right through LA Harbor. The Whittier area has hills behind it because there's a fault called the Whittier Fault that could probably produce a magnitude 7 right at the base of the hills. The Santa Monica Mountains, Hollywood Hills, I've talked about. The Verdugo Hills have a fault running right along near the I-5, just east of Burbank Airport. The Santa Susanas, we know, rose during this earthquake. The San Gabriels have a big fault along the base of them. So it's tough to get away from earthquake hazard here in the metropolitan region, so we really do have to deal with the hazard. And West Hollywood isn't particularly disadvantaged in this regard, and neither is Northridge or Granada Hills. Next. Okay, well, this is a Thomas Brothers map. Don't tell anybody I'm using it, so I don't have to pay for it. But we're looking at a particular area, including the Baldwin Hills here, and let's see if I can figure out what's what. This is the 405, and this is the unfinished Century Freeway. And let's look at an overlay now on the next slide, and it'll show you what the state has done for us. The state has actually zoned the active earthquake faults that break the surface. So when you drive down La Cienega Boulevard, here I think, you'll be crossing, when you first enter the Baldwin Hills, you cross the Newport Inglewood Fault. Okay? And if you're going to build in this zone, you have to do special studies. You have to hire a geologist, pay him $10,000 or so to tell you where the faults are and aren't, so you can miss building on the fault. This is called the Alquist Priolo Special Studies Zone Act. It's also known in the trade as the Geologist Full Employment Act. Now, those zones don't exist in West Hollywood or in Hollywood because the faults, as I explained earlier, were not well known when this law went into effect. They may become zoned in the next few years. Now, just peeking into this particular page of the Thomas Brothers map is a little orange stippled zone. The next slide shows the next map over to the left, which includes Marina del Rey. No, it doesn't. Sorry. This is a map that shows in orange places in the metropolitan region, Southgate, Palos Verdes Peninsula, Long Beach, the harbor, places where liquefaction is most likely during big earthquakes. So places where the ground because of the shaking, is likely to turn to quicksand. Now, some of that actually happened here at Redondo Beach during the earthquake. But let's just talk now about the area of liquefaction here, away from where we live, the marina. And then we're going to talk about little areas of liquefaction. I can't tell which it is, but right up in here, that's actually in West Hollywood. And then I'll end. Next. Okay, so here's the marina. Here again is here's Lincoln Boulevard, and this is the Santa Monica Freeway. Next slide is the overlay of that map, and it shows that the better part of the marina actually is in materials that are very, very young and unconsolidated, very loose, and they have water saturating them up to within a few feet of the surface. So these are prime candidates for liquefying during big earthquakes. Liquefaction disturbs the ground surface. It can cause the breakage of pipes, gas, water, the breaking up of roads, settling of foundations. It's a very serious business when it happens in a major way. Next. Let's now look at our neck of the woods. Let's look at West Hollywood, which is right here. We tonight are sitting right there, I think. There's the Pacific Design Center. Okay, so keep in mind this little southern appendage of West Hollywood. Next. Same map with a little liquefaction potential slapped on top. Here's Santa Monica Boulevard. So basically south of Santa Monica Boulevard, underneath us here tonight, going all the way over to La Cienega and a little beyond, and all the way to Robertson and a little beyond into Beverly Hills. Liquefaction is not a respecter of high-priced real estate. All this area has been judged by the U.S. government geologists to be potentially liquefiable. So this is a problem that I think that the city needs to deal with somehow, and I don't know the answers as to how to deal with that. I mean, there are engineering ways to deal with liquefaction. One thing you can do is you can pump the water table down so that it's so deep that the sediments don't liquefy. The other thing you can do is put gravel pipes down that allow the pressure to be relieved during the earthquake before the ground turns to quicksand. So, to summarize then, there are a couple of hazards here in town. One is the liquefaction potential, which varies with the season. When it's wetter, it's a bigger area. When it's drier, it's a smaller area. The other hazard is the fault running along the base of the hills here, north of Hollywood Boulevard, then down along the strip here, and into Beverly Hills, and then these hidden structures that are down in this area, the Wilshire Fault. Okay, so why don't I stop there? I've probably taken a little bit longer than I intended, and we can take a few questions. No questions? Great.
In your opinion, what can we do to prepare ourselves as a city for an earthquake of large magnitude as far as infrastructure goes?
I'm not really competent to answer the question because I'm not an engineer, but I was beginning to touch on that here with the last slide. The liquefaction potential is one that you need to have your engineers take a look at. Is there something you can do to perpetually lower the water table below, say, 30 feet so that the ground simply isn't saturated and can't liquefy? In the case of particular pricey structures like the Pacific Design Center, it may be, or the Beverly Center, it may be they already have engineered the ground by putting these big gravel pipes into the ground that will alleviate the pressure during the earthquake shaking, and liquefaction won't happen. But there are engineering solutions, and I think it's important for those of you who live here in town to see to it that your government and has the right engineers or right consultants to advise them as to what to do.
Given the high water table here, would a major earthquake cause very different damage in West Hollywood than happened in Northridge in that magnitude of a quake?
The area west of the epicenter actually had fairly high water tables, and it was an area like this area that was recognized to have liquefaction potential. Surprisingly, actually, to most of us geologists, very little liquefaction happened in the areas where we expected it to happen in the Northridge earthquake. So that's a piece of good news. For whatever reason, we're not quite sure yet, but it may be that the water tables are lower because of the 7-year drought. They may actually be lower than they were when these studies were conducted. So lower. But basically, the answer to your question is no. I think we can expect about the same kinds of damage related to liquefaction that occurred in the valley. In the case of the Wilshire Fault moving, a magnitude 6.5 earthquake or so, I think you'd see a lot of disruption of pavement, a lot of disruption of pipelines, especially in the area shown with the stipple pattern.
This question is, how would the big one, and I'm talking about naturally the big one, affect us compared to the Northridge quake?
Those of us who deal with the media a lot are continually bombarded by this question about the big one. And what we've begun to realize since we've been studying the faults in the LA region and over the last 5 or 6 years is that there are a couple of different big ones. The big one on the San Andreas Fault is going to be like a magnitude 8 earthquake. And it's going to be produced by a couple hundred miles of rupture along the San Andreas Fault. It's going to be a very long earthquake. It'll be felt for a long time. You'll probably feel a minute or a minute and a half of shaking rather than, say, 15 seconds or 30 seconds. But it's farther away. And so the energy, as it comes through the mountains, it attenuates, it dies off. So just like we didn't feel as strong a shaking, I happened to be in Lake Arrowhead during the earthquake. I didn't feel as much shaking as you all felt down here, even though it lasted about the same amount of time. So the energy dissipates as it comes towards you. So the big one on the San Andreas Fault is probably not going to shake you as severely as the earthquake in Northridge did, because that source, that fault, was closer. But the fault was smaller, so the shaking didn't last as long. So you're going to feel more of a rolling motion, and it's going to last for a minute and a half or so during the earthquake when the big one happens. In my opinion, the big one that we really have to worry about is the possibility of the faults all the way from Santa Monica through West Hollywood, through Los Angeles to Whittier, all breaking in one magnitude 7 or 7.5. If that happens, heaven help us.
Some newspaper articles have claimed that an 8.0 earthquake would be 125 times greater in magnitude than the 6.7 we just experienced. Is this true?
When you, if Robert were to stand up right now, you could say, "Is Robert bigger than me?" And there would be many different ways to measure that. You could measure height. You could measure distance between pupils. You could measure nose size. You could measure intelligence. You could measure brain size. The same thing is true with foot. You know, your feet might be bigger than mine. The same thing is true of earthquakes. When you try to assign one number to an earthquake, you don't really capture everything about that earthquake. So when scientists say that a magnitude 8 is releases 1,000 times more energy than a magnitude 6, it's very deceptive. That doesn't mean that standing here, I'm going to feel 1,000 times stronger shaking. What it means is that because the fault is so much bigger, a much, much larger area is going to be shaken severely. Okay, so whereas just the northern San Fernando Valley had intensity 9, or very severe shaking, maybe an area of 5 or 6 or 7 square miles, in the great earthquake, that same level of shaking will be felt over maybe a few hundred square miles. So when we talk about the energy being 100 times greater, don't worry that the shaking is going to be 100 times more than what you felt in the Northridge earthquake. It'll probably be very similar to what you felt in the Northridge earthquake, maybe a tad bigger, but it'll last a lot longer. You'll have a lot of time to think. You'll probably run in the house, out of the house, back in again, out, back in, You'll have lots of opportunities to do silly things, more than you had during the 15 seconds or 25 seconds that you had last month.
Is there any danger from tidal waves if the fault, like the Santa Monica fault, ruptured? And if so, how large an area could it affect?
When you listen to geologists talk about hazards, you always have to take it with a grain of salt, because we talk about things happening over thousands of years and millions of years. What you're interested in is whether it's going to happen in the next 50. There has never been a tsunami, which is the technical word for a tidal wave caused by an earthquake. There's never been a destructive tidal wave or tsunami in Southern California in the entire historical period. So the chances of it happening are very, very slim. We do have structures, though, that faults that break the surface beneath the ocean. And if they were to move, say the one that is near San Clemente Island or Santa Catalina Island, they could displace water above them and cause an onrush of water onto the beaches. They would certainly not run up more than a few tens of feet. You might have problems with a PCH and so on, but it's not a hazard to us here in West Hollywood. At least not for another few million years. I should point out, by the way, that this used to be the shoreline right along here. That was about 1 million years ago. You could fish right off of Sunset Boulevard. You could fish right out of Spago's.
This question is, does one earthquake put stress on another fault or other faults and cause other quakes?
Barry, if we could go back about 3 or 4 slides, I can answer that question better with an illustration. Keep it going. More. Again. 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 It's more than 4. Go ahead. Okay, more. Again. About 3 more. Okay, oops, that's too far. Right there. Okay. Here's the rupture area, or the aftershock pattern of the 1971 earthquake. Notice that the Northridge earthquake aftershock zone is kissing cousin. Okay, they're right next to each other. And there's a lot of talk just in the past few weeks among us scientists that, in fact, the San Fernando fault, by breaking, it basically said, I give up, I'm going to give my burden to my neighbors. So it loaded up this part of the San Gabriel Mountains, and it loaded up this part of the Santa Monica, or the San Fernando Valley. So some scientists are now speculating that this earthquake, in fact, accelerated the day that this particular neighbor was going to also fail. So we do have some concerns, although we haven't, we have nothing public to say about it, in terms of certainty. But we do have concerns that this now and this, both going in 20 some odd years, could in fact trigger more earthquakes off the end, or even here in the Santa Monica Mountains area. But they're very, they're nebulous concerns. They're nothing that you need to feel alarmed about.
What was the geological cause of the earthquake damage in Santa Monica?
I have no idea. The damage along the 10 near Fairfax and the I-10 probably has to do with that particular area being built on old marshy ground that was not very suitable for structures. The damage in much of the San Fernando Valley probably also has to do with it being built on ground that had high water table. I have not yet heard a single person advance a credible hypothesis as to why the damage occurred so severely in Santa Monica. I just don't know.
Given the new fault information obtained during the past year, have you given thought to moving from the area?
Hey, this is my bread and butter. I grew up in Iowa, and I remember as a child seeing a couple of funnel clouds, and they scared me an awful lot more than earthquakes. I have research projects in foreign countries, and when I'm working in Indonesia or the People's Republic of China, third world countries, I'm scared of staying in the hotels or staying in single-story buildings that are concrete slab buildings, because when earthquakes happen in those countries, the buildings collapse. Many buildings collapse, and tens of thousands of people are killed. A magnitude 5.5 in Nicaragua in 1962 killed 10,000 people. A 5.5 right beneath us here might cause $30 million in damage, but it's not going to kill more than a handful of us. So I think that those who went before us had engineers who were competent enough to design buildings for us that are not, for the most part, going to collapse. I'm therefore not all that scared of being in California when there are earthquakes.
This next question is, developers frequently call to find out if they would be developing on a fault. Is it possible to know this, and would it make any difference if you were on a fault as opposed to very close to one?
As I was saying during when I was showing some of the slides, it makes a very big difference whether you're on a fault or whether you're even a few tens of feet off a fault. So I'm going to actually be pushing, and I hope there are no developers in the audience with weapons, but I'm going to be pushing that the Santa Monica and Hollywood faults be zoned so that buyers of single-family homes and buyers of apartments and buyers of buildings, commercial buildings, know before they buy them what they're buying and what the potential hazard is. Buildings that are rent in two by earthquake faults are basically condemnatory level damage. You usually cannot repair those buildings. They have to be torn down. Buildings that are even a few tens of feet off faults, although they may sustain severe shaking damage, that's a whole different issue. They don't have this problem of having their foundations differentially shifted. in having their, the homes going from ranch tile to split level. So it makes a huge difference.
Would it be worthwhile, and what would it involve for the city to do a seismic study of the area for planning future developments?
I would hope that one of the reasons I agreed to give this talk, actually, was that I hoped that it would inspire the citizens of West Hollywood and the local authorities here to hire a geotechnical consultant to look into the liquefaction potential and to look into the fault location, the fault problem. So that's one of the reasons I came here tonight. I hope that you guys will treat this more than just as entertainment, but as a beginning to start dealing in a serious, long-term fashion with your faulting hazard and with your liquefaction hazard. Now, lucky for you, you don't have to worry about landslides because none of the city is up in the mountains, right? You can leave that to Beverly Hills.
It sometimes seems as though the cumulative effects of the aftershocks cause as much or more damage than the original quake. Is this true, and could you discuss this?
In this particular earthquake, that hasn't been the case. In this particular earthquake, by far the greatest damage, the tens of billions of dollars happened in the main shock. There are notorious examples around the world, though, of where the aftershocks did more damage than the main shock. For example, 1952, Bakersfield. The main shock was a magnitude 7.7, biggest earthquake since 1906. The aftershock of 6.4 occurred closer to Bakersfield and produced more damage in Bakersfield than the main shock, which was an order of magnitude bigger. In China, in 1976, a magnitude 7.5 earthquake, killed about 500,000 people, but two of the aftershocks, which were magnitude 7s, did killed tens of thousands of people as well. So aftershocks can be very serious matter. Usually for an earthquake as small as a 6.5 like this one, however, the main shock is the one that does the most damage.
This question from the audience, is there a theory that explains why 2/3 of the earthquakes occur in the early morning hours?
It's true that in California, a disproportionate share of the damaging earthquakes in our history have been in the early morning. And as a scientist, I would have to say I think that's coincidental. But you know how that goes. Eventually somebody will have a hypothesis, they'll test it with some physics and mathematics, and they'll say, why didn't we know this before? Those scientists that preceded us were stupid. So it's a correct observation that, especially in the last 10 years, most of our damaging earthquakes have happened 5 o'clock, 6 o'clock in the morning, and nobody has advanced a theory. My guess is it's just purely statistical fluctuation.
How possible is it really to predict earthquakes?
There are three different types of predictions. One is long-term. For example, we've forecast the San Andreas Fault has about a 30% chance of breaking with a magnitude 8 in the next 30 years. Okay, that's one type of forecast. It's a long-term forecast. It impacts long-term development plans and so on. Short-term forecast, let's just make two different possibilities here. Short-term forecasts would be forecasts that are made in the hours or in the minutes or the days or weeks prior to an earthquake. That at the present time is pure fantasy. Nobody that I know in the business has a serious hypothesis or theory that allows them to predict short-term over a period of seconds or hours or days or weeks earthquakes. So if you hear a short-term prediction that Caltech scientists are predicting an earthquake next week in a specific place and specific magnitude, you can automatically know it's not true. Okay. Frankly, I think that short-term prediction has some problems, even if it were doable. Imagine, for example, the Loma Prieta earthquake in 1989 in the Bay Area. Imagine if there had been a prediction an hour before the earthquake. Imagine how many people would have died in Candlestick Park trying to get out of the World Series. Imagine how many people would have died on the viaduct going out of town that collapsed. Okay? So the panic that would ensue after a short-term prediction could very well cause more human losses than if the earthquake wasn't predicted. Now, you could say that's sour grapes, that we can't do it, therefore it isn't worth doing. But I think that by far the biggest effect we can have is with long-term forecasts like we're currently making, talking about where the faults are, how big the earthquakes are likely to be, how often they occur, and so on. That's going to affect how this building is designed. Are we going to keep putting these tiles in the ceiling that fall down? No? Are we going to keep doing that since we know long-term we're likely to have shaking again?
An audience member asked, since West Hollywood is about 25 miles from the epicenter, did what we feel was what we felt a lot less than the 6.8 shaking? About what magnitude did we feel here?
If you go back to the back table after the talk, you'll see a beautiful map that the Federal Emergency Management Agency has put together on the middle table, and it shows what's called modified Mercalli intensity. Mercalli was an Italian. He invented a scale called the Mercalli scale, which measured how strong the shaking was at any one place. Okay? The shaking in the area around Northridge and Granada Hills was a level 9. The shaking here was level 7. It was strong enough here that I imagine you probably would have had a hard time walking, right, if you tried to walk? Well, in Northridge, it wasn't a question. That wasn't an issue. Okay, the damage, you'll see that the building damage was far more severe in the intensity 9 region than it was here. So there's no doubt you did not experience anywhere near the strength of the shaking that they felt during the earthquake, nor did the buildings. Okay, the magnitude is another matter. The magnitude is a number that expresses how big the source was, how big the fault was that broke. So you felt a 6.8. They felt a 6.8. They were just a lot closer. So it was a lot stronger. So that's the difference between intensity of shaking and the magnitude of the earthquake. There's one or a couple of numbers that express the magnitude of the earthquake, and that doesn't change depending on where you are. The intensity decreases as you go out away from the source.
This question almost ties into anthropology. It says, do you have any information from the indigenous people who've lived here for thousands of years about earthquakes that have occurred within their native history of any kind?
The Native Americans who lived here did not leave any written records, and there are very sparse oral traditions. There's a story about an earthquake up near Mammoth about 1780 that we know of because of those oral traditions. There's an earthquake probably on the San Andreas Fault out near Palm Springs that happened sometime in maybe 300 years ago or so. But there's no really useful data from Native Americans prior to the settlement. The first earthquake we know anything at all about was the earthquake that occurred while Gaspar de Portola was coming up through Santa Ana Canyon and up into the LA Basin in July of 1769. And he says that a very severe earthquake struck, and that we all fell to our knees, and it lasted half as long as a Hail Mary. So we know it was probably about a magnitude 6.5 because of the duration of the earthquake shaking. But other than that, we don't have the advantage that we have, say, in the Pacific Northwest, where the Indians were more agricultural, and so they actually had a stronger oral tradition than the more nomadic Native Americans here.
The latest news is that additional stress has been put onto the Inglewood, Wilshire, and other local faults. Is this true? And how intense could this affect us?
It is true, and the calculations have just been presented in the past week or so at a scientific meeting last week, and it's true that many of the faults surrounding the fault that broke in the earthquake have been stressed more greatly than they were prior to the earthquake. What you have to bear in mind is that this is like putting another rider on the camel. You know, how many riders can you put on the camel before the camel's knees buckle? That's the problem. We don't know the answer to that question. So just like it took San Fernando, it took 20 years following San Fernando for the Northridge earthquake to finally happen. We don't really know whether the amount of stress that was added to the adjacent faults is enough to accelerate or to advance the occurrence of the next damaging earthquake a month, a year, 10 years, or 50 years. We just don't know.
This is a question from an audience member who lives on the 9th floor of Shoreham Towers, which is a 13th-story building. She's asking, is she safer there on the 9th floor, or would she be better on the 3rd floor? And what could happen to a high-rise building? If it's not on rollers, this building is not on rollers.
I probably shouldn't speculate because I don't know where that building is, and I'm not an engineer. There was a very good article yesterday in the LA Times and the Sunday Times about the high-rise, the metal, the steel frame high-rises in the downtown, in the metropolitan area, and you might just go hunt that up and take a look at that. For the most part, the engineers are fairly confident that the high-rise structures, the metal frame structures, are going to perform very well in the next earthquakes. Still of the greatest concern are the unreinforced buildings. Most of the unreinforced buildings in the city of LA have now been either retrofitted or abandoned since the ordinance was passed in 1980. Enforcement was accelerated following the Mexico City earthquake in '85. So we are slowly but surely, at least in the city of Los Angeles, I don't know what's happened in the other smaller communities around Los Angeles City, but we are slowly but surely taking care of these buildings that we know are structurally unsound.
This is a two-part question. The first part is, what is the worst-case scenario for liquefaction in West Hollywood? And the second part is there any chance that California will sink and Las Vegas will become beachfront property?
You know, if you bought a house in Hancock Park in 1906, it would have cost you about $5,000, and it would now cost you about $1 million. But I don't know many people who can wait around that long. So, if you want to, if you can afford to wait for say 3 or 4 million years, you probably could get some a steal on some beachfront property in Lake Arrowhead, or up in the San Bernardino Mountains. But yeah, you know, one thing, the greatest truth in geology is that everything changes. The mountains go down, the valleys come up. Okay. As far as liquefaction is concerned, I'm not really in the business of trying to do what the press does so well, and that is to amplify or exaggerate the likely consequences of an earthquake. But the best case scenario, I think, for liquefaction in West Hollywood is that the earthquake that occurs near us here would occur during the dry season, after a prolonged drought, and the water table had dropped precipitously, and we still had enough water to drink, so that the water tables were so low that liquefaction simply did not happen in West Hollywood. The worst case scenario would be when, you know, in a rainy year or a series of rainy years, the water table is flooding basements right around here, and people are complaining to the city council about that, and nothing's being done about it, and then the earthquake happens, and if that were the case, you could expect to have, you know, major fissures running across San Vicente and other streets in the vicinity, and those fissures would entail the rupture of water mains and gas mains, and it'd be a pretty difficult situation. There'd be a lot of houses that would be, foundations would be broken and so on. So, but you know, I'm addressing this in a very generic fashion. I think it really would behoove you guys to have an engineer or a geotechnical person look at this more carefully.
This is the last question. Can the city do anything to avoid major fires and explosions during a large earthquake?
That probably is the most important question that, in terms of engineering for West Hollywood. And I think the things you can do are what I've said. You can over the long term start dealing with the fact that you do have faults in town that will break the surface and will break the pipes. There must be some way that some clever engineer can mitigate against that eventuality, like automatic shut-off valves on either side of the rupture of the pipes or something. And the other thing you can do is lessen the liquefaction potential, so you don't have to worry as much about the southern part of the city having superficial breaks that would break the roads and the pipes. Well, if that's the last question, thank you very much for your coming, and I enjoyed the time. I hope you learned something.
On behalf of the Disaster Preparedness Committee and everyone else who's here, I'd like to thank you again for taking your time to come out and speak with us this evening. We really appreciate that. Help us better understand the faults that are in our area. And with that, I want to thank you again, and good night, everybody.